China's lunar probe has returned to Earth with its samples from the unexplored far side of the moon.
China's lunar missions have done more than explore the moon. They've rewritten its story. From mysterious far-side samples to minerals that could power future reactors, China's discoveries reveal a moon that's alive with chemistry, energy, and potential. This is the real story of what China found up there and how it could change everything on Earth. Lunar Origin Mystery. The moon isn't just a glowing ornament in the night sky. It's a geological time capsule and a stabilizer for life on Earth. Its gravity controls our tides, shapes our climate rhythms, and even steadies the tilt of our planet's axis. But behind that soft glow is one of science's biggest puzzles. Why is our moon so large compared to the planet it orbits? When you look around the solar system, Earth's setup seems oddly unique. Venus, almost identical in size to Earth, has no moon at all. Mars has 2, but they're barely bigger than mountains. Phobos is about 14 miles wide, Deimos only 8. And while the gas giants have huge moons, they're also hundreds of times larger than Earth. Our moon, measuring roughly 2,159 miles across, sits somewhere in the middle. Too big to be a coincidence, too strange to ignore. The first real clues came from the Apollo missions. When astronauts brought lunar rocks home, scientists compared their isotopes to Earth's crust, and the match was uncanny. The chemistry was nearly identical, as if the moon had been born from Earth itself, not captured later by gravity. Those rocks also showed low levels of volatile elements and a much smaller iron core, hinting at a violent birth. That led to the giant impact hypothesis, often called the Big Splash. Around 4.5 billion years ago, a Mars-sized object slammed into the young Earth, vaporizing rock and throwing molten debris into orbit. Over time, that debris cooled and clumped together, becoming the moon we see today. The shared chemistry, the lack of iron, and even the Earth-Moon spin all make sense under this theory. But the mystery doesn't end there. The moon is tidally locked, showing us only one face, yet its 2 hemispheres are completely different. The near side is dark and flat. The far side is pale and heavily cratered. Ancient magnetism in lunar rocks suggests it once had a molten core and a global magnetic field, even long after it should have cooled. Hidden beneath those dark planes are mascons, buried concentrations of mass that subtly tug on orbiters, revealing a far more complex interior than anyone expected. Every layer of the moon's story is a snapshot of the early solar system, a record of chaos and creation that Earth's own surface has long erased. Understanding how our moon formed isn't just curiosity. It's the key to knowing how habitable worlds like ours come to be. China's moon quest. For decades, space exploration was dominated by 2 flags: the stars and stripes of the United States and the hammer and sickle of the old Soviet Union. In the early 2000s, China made a decision that would redefine the moon's future. They launched the Chang'e program, named after the Chinese goddess of the moon, a name both poetic and deliberate. The message was clear. China wasn't just sending machines into space, it was claiming a seat at the table of cosmic discovery. The Chang'e project was laid out in 4 precise stages, each one a building block for the next. First, orbit the moon. Second, land on it. Third, bring samples home. And finally, prepare for long-term human presence. No guesswork, half measures. Every mission had a purpose, every step part of a long game. The first milestone came in 2007 with Chang'e-1, a lunar orbiter that mapped the entire moon in 3 dimensions. It gave China the most detailed elevation data ever collected at that time. Mountains, craters, and ridges rendered in astonishing clarity. 2 years later came Chang'e-2, flying lower and faster, capturing sharper images, and even testing deep space tracking by swinging past an asteroid millions of miles away. Then came the leap that changed everything. In 2013, Chang'e 3 made the first soft landing on the moon since the 1970s. The lander carried a small six-wheeled rover named U2, or Jade Rabbit. It roamed across the dark volcanic plains of Mare Imbrium, studying minerals, scanning underground layers, and measuring radiation. The mission lasted far longer than expected, proving that China's engineering could survive the extremes of lunar day and night. This wasn't just science, it was a declaration. China had entered the elite club of moonlanders, joining only the US and the Soviet Union. But the difference was in the intent. Where the others had stopped decades earlier, China was only getting started. Their next challenge was communication. The far side of the moon is permanently hidden from Earth. Radio signals can't reach it directly. So before their next mission, China launched a relay satellite called Queqiao, parked 37,000 miles beyond the moon at a gravitational balance point known as Earth-Moon L2. It was a technological masterpiece, able to bounce signals between Earth and the far side in real time. With Queqiao in place, China prepared for its most daring move. Chang'e 4, the first mission in history to land on the moon's hidden hemisphere. The world watched as the lander touched down inside the von Karman crater in 2019, a world first, and the moment China's quiet ambition became undeniable. Behind these missions was more than curiosity. The moon represents resources, energy, and strategic power. Inside its dust lie potential fuels like helium-3, metals for manufacturing, and frozen water that could sustain human bases. China's steady investment wasn't just about science, it was about securing the future economy of space. In 2020, Chang'e 5 sealed the proof of concept. The probe drilled into lunar soil, collected samples, launched itself back into orbit, and returned them safely to Earth. The first successful sample return mission in more than 40 years. In one stroke, China showed that it could complete the entire chain of lunar operations: orbit, landing, collection, ascent, and re-entry with robotic precision. Each of these steps built momentum for what would come next: new landings, deeper drilling, and plans for a permanent base at the moon's south pole. The Chang'e program wasn't just a series of missions, it was a roadmap, one that would carry China from exploration to occupation. While other nations debated budgets and politics, China was already walking on the moon again, through its machines, through its data, and through its vision of a future where the lunar surface isn't a mystery, but a new frontier waiting to be lived on. The hidden face. For as long as humans have looked up, we've only ever seen one face of the moon. The other half, the far side, stayed hidden for all of history. No telescope, camera, or astronaut had ever seen it directly. It was invisible to Earth, locked in eternal shadow. That is, until China decided to go there. In January 2019, China's Chang'e 4 mission did what no country had ever done before. It landed on the far side of the moon. The world watched as a small robotic lander touched down inside the von Karman crater, a massive depression in the moon's southern hemisphere. This was history. For the first time, humanity had reached the side of the moon that never faces Earth. But landing there wasn't easy. Because the far side is always turned away, no radio signal can reach it directly. To make it possible, China launched a relay satellite called Queqiao, positioned beyond the moon at a stable point in space. From there, it acted like a mirror for data, bouncing signals between Earth and the lander. It was an elegant solution to a problem no one else had solved. The lander carried a small rover called U22, or Jade Rabbit 2. At only about 310 pounds, it looked small and harmless, but this machine would rewrite what we knew about the moon. As soon as it rolled onto the surface, it began sending back images that shocked scientists. Then, U-22 found something even stranger. Using its ground-penetrating radar, it looked beneath the surface, and what it saw was complex. Multiple layers of rock, dust, and buried lava flows stacked like a record of billions of years of impacts and eruptions. Scientists counted at least 9 separate layers, each marking a different era of the moon's violent history. That alone changed what we thought the far side was. Not a static, frozen wasteland, but a planet's crust that had lived through unimaginable change. But the biggest discovery was buried in the rocks themselves. When scientists analyzed the data, they realized that some materials U-22 found didn't belong on the surface at all. They had likely come from deep inside the moon, the mantle, a region that no previous mission had ever accessed. It was the first evidence of lunar mantle material exposed by ancient impacts. For scientists, this was like finding the moon's DNA, the deep chemistry that could explain how it formed and evolved. And then, something unexpected captured the world's attention: a cube-shaped object on the horizon. In December 2021, U-22 spotted it. A strange, boxy silhouette sitting miles away, perfectly square against the barren landscape. The image went viral. Was it an alien structure? A lost spacecraft? A secret base? For weeks, people speculated. Even China's space agency called it the Mystery Hut. The rover crept toward it slowly, taking weeks to cross the crater floor. When it finally got close, the mystery vanished. It was just a rock. Its strange shape had been a trick of light, shadow, and low-resolution pixels. Yet for a moment, that cube reminded the world how easily the unknown can spark our imagination. Beyond the jokes and memes, the Chang'e 4 mission accomplished something monumental. It showed that the far side of the moon is not a mirror image of the near side. It has a thicker crust, a different mineral makeup, and a colder mantle beneath. It cooled faster. It evolved differently, and it still holds mysteries that no camera or rover has fully uncovered. China's tiny jade-colored rover became the first messenger from a place humanity had never seen. And what it found beneath the dust proved that the moon's hidden face is far more complex, ancient, and alive with history than anyone ever imagined. Secrets beneath the surface. In late 2020, as most of the world was focused on life here on Earth, China quietly made history. Again. A spacecraft called Chang'e 5 landed on the moon's near side, in a place no one had visited in nearly half a century. Its mission: collect samples, bring them home, and answer a question that's been haunting scientists for decades. Is the moon truly dead? The landing site wasn't random. It was a smooth region known as Oceanus Procellarum, the Ocean of Storms. Nestled near its edge is a volcanic dome called Mons Rumker, a broad mound formed by slow eruptions billions of years ago. Most missions had landed on the older, flatter plains. China wanted something different: younger volcanic rock, clues to a later and longer life inside the moon. Chang'e 5 touched down on December 1st, 2020. It unfolded its instruments, drilled down about 6.5 feet, and scooped up surface dust and rock. Within 48 hours, it had sealed nearly 4 pounds of lunar material into a metal container. Then, in one of the most technically complex robotic maneuvers ever attempted, a small ascent vehicle blasted off from the moon, docked with the orbiter above, and began the long journey home. 2 weeks later, a capsule fell through Earth's atmosphere and landed softly in the snow of Inner Mongolia. Inside, it was something humanity hadn't touched since the Apollo era: new moon rocks, and they were nothing like the old ones. Under microscopes in Beijing, scientists were stunned. These samples were much younger than expected, only about 1.97 billion years old. That's a full billion years younger than any Apollo rock. This meant that volcanic activity on the moon didn't end when we thought it did. Somehow, long after the surface should have cooled solid, lava was still flowing. What could have kept the moon's heart warm for so long? That question alone forced scientists to rethink everything they thought they knew about lunar geology. But age wasn't the only surprise. Buried in the grains of basalt, researchers found something the world had never seen before: a brand new mineral. Transparent, crystal clear, and smaller than a human hair, it shimmered under the microscope. They named it Changesite Y. That tiny crystal was more than a mineral. It was a promise of unlimited energy. But that wasn't the only revelation waiting inside the dust. It likely emerged when solar wind particles hit iron-rich dust, generating brief bursts of heat that reorganized carbon into perfect atomic layers. It was the first proof that the moon's chemistry could create advanced materials naturally. In one mission, China had found a new mineral, natural graphene, lunar water, and proof of younger volcanism. It was a scientific jackpot, evidence that the moon was far more dynamic and resource-rich than anyone expected. And for the first time since Apollo, humanity was holding new pieces of another world in its hands. The far side's return. By 2024, China had already conquered half of the moon. It had mapped it, landed on it, and brought back samples from its volcanic plains. But there was one frontier left: the far side, the hemisphere that never faces Earth. No one had ever returned samples from there. No one even knew exactly what they would find. The Chang'e 6 mission was built to answer that question. Launched in May 2024, it was designed as the most complex robotic operation in lunar history. The goal was bold: land on the moon's far side, collect rock and dust, and bring them home. The site chosen was the South Pole Aitken Basin, a colossal impact crater stretching nearly 1,550 miles across and plunging more than 5 miles deep. It's one of the oldest scars in the entire solar system, formed nearly 4 billion years ago when a massive asteroid smashed into the moon. Scientists believed that this ancient wound might expose materials from deep inside the lunar crust and mantle, a place no probe had ever touched. The landing itself was a masterpiece of precision. The surface near the moon's south pole is a jagged maze of cliffs, ridges, and shadowed craters where sunlight never reaches. But Chang'e 6 touched down perfectly, thanks to an upgraded Quiqiao 2 relay satellite parked far beyond the moon to maintain constant communication with Earth. Once on the ground, the lander drilled, scooped, and stored about 4.4 pounds of soil and rock, the first samples ever taken from the moon's hidden hemisphere. When the capsule finally returned to Earth, scientists began to see what made the far side so different. First, the samples looked nothing like those from the near side. They were lighter in color, richer in plagioclase feldspar, and poorer in olivine, minerals that form under different cooling conditions. But there were also surprises. Among the ancient fragments, scientists found traces of relatively young volcanic glass, only about 2.8 billion years old. That meant the far side wasn't completely geologically dead. It had erupted long after it should have frozen solid. The discovery shattered previous models of lunar cooling and hinted that some pockets of molten material may have persisted far longer beneath the crust than anyone imagined. Even more intriguing were tiny mineral inclusions showing chemical fingerprints that matched material from the moon's mantle. That confirmed what scientists had hoped. The South Pole Aitken Basin impact had punched so deep that it had actually excavated rock from the moon's interior. For the first time in human history, we were holding pieces of the moon's lower layers in our hands. Chang'e 6 didn't just rewrite what we know about the moon, it deepened the mystery. The far side wasn't just a colder twin of the near side, it was a geological opposite. It had evolved under different conditions, cooled at a different rate, and held onto different materials. The mission also pushed technology to its limit. Every step, from autonomous landing to sample ascent, orbital docking, and return, was done without real-time control from Earth. That level of independence will be crucial for future interplanetary missions, including Mars sample returns and human outposts. In a single mission, China did something no one else had ever done. It brought back the unseen side of the moon, and what it revealed was staggering. A colder, thicker crust, younger volcanic deposits, and clues that the moon's interior may still hold heat today. The far side, once just a poetic mystery, had finally told its story. And now, humanity understood something profound. The moon is not one world, but two. Two faces, two histories, and two destinies carved into the same silent sphere. Unexpected chemistry. When China's Chang'e 5 and Chang'e 6 samples were finally opened in clean labs back on Earth, scientists expected to find rocks, glass beads, and dust, the usual relics of a dead world. But inside those tiny gray grains, they discovered something no one had ever imagined. The moon was still chemically alive. For decades, researchers had believed that the moon was dry, inert, and carbon-poor. Apollo samples supported that idea. Barely any carbon, no trace of organic complexity, and no sign of the chemistry that shapes active planets. But then, under high-powered microscopes, Chinese scientists spotted something that changed everything. Inside the dust, they found thin carbon sheets only a few atoms thick, unmistakable graphene. This wasn't man-made or laboratory-grown. It had formed naturally right there on the moon. At first, no one could believe it. A research team led by Wei Jiang at Jilin University began studying the strange signal patterns from these samples. The spectral fingerprints matched perfectly with multi-layer graphene, carbon sheets stacked between 2 and 10 atoms thick. That meant this wasn't contamination or random soot. It was genuine crystalline carbon created by natural processes. Their theory was simple, but revolutionary. The moon, lacking an atmosphere, is constantly bombarded by solar wind, streams of high-energy protons and ions traveling at over 250 miles per second. When these particles slam into iron-rich dust grains, they can momentarily heat them above 2,000 degrees Fahrenheit, just enough to melt and rearrange atoms. Under those violent flashes, carbon atoms bond into hexagonal networks, graphene. In other words, the moon has been making graphene naturally for billions of years. That realization opened an entirely new branch of lunar science. Either scenario reshapes how scientists think about the moon's chemistry and its relationship to Earth. The graphene samples weren't alone. In the same soil, scientists found traces of nitrogen, sulfur, and molybdenum, elements that rarely appear together without complex chemical reactions. Some carbon layers were wrapped around metallic nanoparticles, forming core shell structures like those seen in certain meteorites. These formations suggested that metallic catalysts helped drive the creation of carbon sheets during short, high-temperature bursts. Even more surprisingly, the moon's dust showed signs of ongoing surface chemistry. Every second, solar wind and micrometeorites continue to reshape the top few microns of lunar soil, fusing, ionizing, and reconfiguring atoms. It means the moon's surface isn't frozen in time. It's a living laboratory of elemental transformation. And this isn't just scientific curiosity. The implications for future exploration are massive. Natural graphene could become a valuable industrial resource. It's ultra-light, incredibly strong, and conducts heat and electricity better than any known metal. Engineers imagine mining or extracting it from regolith to build radiation shields, solar panels, water filters, and supercapacitors right on the moon. If humanity ever establishes a permanent lunar base, these materials could be used to construct and power it, using nothing but the moon's own chemistry. The discovery also forced scientists to revisit the giant impact theory itself. If the moon really formed from the molten debris of a collision with early Earth, it should have lost nearly all its carbon. Yet here we are, holding carbon sheets and catalytic metals. That means either the impact wasn't as violent as once thought, or the moon later reabsorbed carbon from solar wind. A slow but steady rain of atoms that's been happening for billions of years. Every sample studied so far tells the same story. The moon isn't chemically dead. It's still reacting, still building, still evolving. Atom by atom, layer by layer. The discovery of natural graphene transformed gray dust into gold. It turned what looked like ordinary regolith into a treasure chest of advanced materials, proof that even in the harshest environment, the universe never stops creating. And as scientists keep analyzing those microscopic structures, one thing becomes clear. The moon is no longer just a place to explore. It's a place to build from, a source of resources, and maybe one day, a foundation for human industry beyond Earth. China's path to lunar settlement. The moon is no longer just a place we visit, it's becoming a place we plan to stay. After years of robotic exploration and sample returns, China's next goal isn't just science, it's presence. The discoveries of helium-3, natural graphene, and lunar water have transformed the moon from a lifeless rock into a strategic treasure chest. Now, China is leading a new kind of space race, not to plant flags, but to build the future. That future begins with a project called the International Lunar Research Station, or ILRS. A plan led by China and joined by Russia, with open invitations to other nations and organizations. Think of it as a permanent, fully automated science base near the moon's south pole, capable of supporting both robots and, eventually, people. Construction is expected to unfold in stages through the 2030s, with Chang'e 7 and Chang'e 8 paving the way. Chang'e 7, scheduled for later this decade, will send a lander, an orbiter, and even a mini flying probe to map the distribution of water ice hidden in the moon's shadowed craters. Its partner mission, Chang'e 8, will go a step further, testing in situ resource utilization, or ISRU, the process of turning local materials into usable resources. That means extracting oxygen, fuel, and building materials straight from lunar soil. The concept is simple. If you can build with what's already there, you no longer have to bring everything from Earth. This is where China's earlier discoveries become the foundation for something larger. And the graphene and metals found in moon dust could be used for 3D printing habitats and solar panels directly on the surface. Each of these resources turns the moon from a barren world into a self-sustaining outpost. The chosen site for this future base is no coincidence. The lunar South Pole offers the perfect conditions: steady sunlight along its high ridges for solar power and permanent darkness inside deep craters that trap frozen water. It's one of the few places on the moon where energy and life support materials can coexist. From here, explorers could stay for months at a time, refuel spacecraft, and prepare for missions even deeper into the solar system. But make no mistake, this isn't just about science. The moon is quickly becoming the next global frontier. The United States, through NASA's Artemis program, plans to land astronauts at the South Pole by the end of this decade. India, Europe, and Japan are all developing their own missions. Yet, China's methodical progress, from Chang'e 1's mapping to Chang'e 5's sample return to Chang'e 6's far side breakthrough, gives it a unique advantage: a complete, self-reliant lunar infrastructure already in motion. For China, the moon isn't the finish line, it's the launch pad. The ILRS is designed to support long-term operations, not just on the moon, but across cislunar space, the vast region between Earth and the moon that could become humanity's next industrial zone. Imagine spacecraft refueling at lunar depots, satellites built in orbit using moon-derived metals, and energy beamed back to Earth through massive solar arrays. That's the vision behind this new space economy. To get there, China is developing technologies that mirror Earth's evolution: mining, manufacturing, and energy production, but in an environment where every atom counts. With automated robots, 3D printers, and modular construction, the moon will become not just a research site, but a living experiment in self-sufficiency. And when humans finally step out onto the moon's southern rim to stay, not just visit, they'll be walking on ground prepared by the machines that came before them. In less than 2 decades, China has gone from its first lunar orbiter to a vision of permanent settlement. What began as a quiet exploration has turned into the blueprint for a civilization that can live beyond Earth. If this blew your mind, hit like, subscribe, and share it with someone who still thinks the moon's just dust and craters.